So today we are going to discuss about preservation of foods. As you know, foods are mainly composed of various biochemical compounds like carbohydrates, proteins, fats as major constituents, and minerals, vitamins, enzymes, acids, antioxidants, pigments, flavors, etc., as minor constituents in the foods. Foods are subject to physical, chemical, as well as biological deterioration because they are perishable in nature. Major factors affecting food spoilage includes growth and activities of microorganisms, be it bacteria, yeast, or molds, activities of food enzymes, and other chemical reactions within food itself. Next one is infestation by insects, rodents, etc. Inappropriate temperatures for a given food. Next one is either the gain or loss of moisture. Next is reaction with oxygen, and last one is light. These are important factors which affect food spoilage. Vast majority of instances of food spoilage is attributed to one of two major causes. First one is attack by microorganisms, be it bacteria, mold, or yeast. And second one is oxidation that causes either destruction of essential biochemical compounds or destruction of plant and animal cells. Chemical or biological reactions result from decomposition of foods due to microbial growth. There is adverse effect even on appearance, flavor, texture, color, consistency, and nutritional quality of the food. What is food preservation? It is a process of treating or handling foods to stop or greatly slow down its spoilage, including loss of quality, edibility, or nutritive value, which is caused or accelerated by different microorganisms. Preservation involves preventing foods from growth of bacteria, fungi, and other microorganisms in foods. Also includes retarding oxidation of fats, which ultimately causes rancidity and spoil the foods. Preservation also involves various processes to inhibit natural aging and discoloration which occur during food preparation. For example, enzymatic browning reaction in apples after they are cut. Preservatives. They may be defined as any chemical compound or process when applied to food, either retard alterations caused by growth of microorganisms or enable physical properties, chemical composition, and nutritive value to remain unaffected by microbial growth in the foods. Now let us see principles of food preservation. First one is prevention or delay of microbial decomposition in the food by keeping out microorganisms known as asepsis. Next one is by removal of microorganisms in the food. By hindering growth and activity of microorganisms may be achieved by low temperatures, drying, anaerobic conditions, or different chemicals used as preservatives. Next one is by killing of microorganisms, that is achieved by heating or by subjecting foods to radiation. Next principle include prevention or delay of self-decomposition of the food, which may be achieved by either destruction or inactivation of different food enzymes present in the foods, that is achieved by blanching. This is the process in which food is kept for few seconds in boiling water in order to inactivate enzymes, which is basically proteinaceous in nature and gets denatured because of treating in the boiling water because of high temperature. Next one is by prevention or delay of chemical reactions by using antioxidant to prevent further oxidation causing rancidity. Methods of food preservation. Food preservation of food is achieved by application of physical methods, chemical methods, or biological methods. We will discuss in detail about all of them. First of all, let us see about physical methods. It includes cooling of the food material. Cooling naturally, it will include either refrigeration temperature, which ranges from 0 to 7 degrees centigrade and preserves foods for shorter period, that is for few days. Even food can be kept in frozen condition to a temperature as low as minus 18 degrees centigrade to preserve for several months. It increases shelf life of the food to a great extent. Next one is heating. This includes pasteurization, cooking, sterilization of the foods, etc. Next one include exposure to ionizing radiation, including UV rays, gamma rays, etc. Next one is application of high pressure, and last physical method includes drying of the food materials. This includes removal of water to a level which does not support further growth of microorganisms. Next method is chemical method. It is quite often that either quite often it is either impossible or undesirable to employ conventional physical methods of preservation. In such situation, one has to opt for chemical methods of preservation. It involves application of chemical additives which act as antimicrobial agents. Next one is biological methods. For this, souring of the product is done because of fermentation, and for this lactic acid, acetic acid, etc. are used for fermentation of the product. For example, this method is applied for preparation of cheese, cultured milk, etc. Now, let us discuss about physical methods, different physical methods. First one is thermal treatment of the product. The term thermal refers to obviously processes involving heat. Heating is an effective way of preserving foods because great majority of harmful pathogens are killed at temperatures close to boiling point of water. Thus, heating is a form of food preservation comparable to that of freezing, but much superior in its effectiveness. A preliminary step in many other forms of food preservation, especially forms that make use of packaging, is to heat the foods to temperatures sufficiently high to destroy different pathogens. In many cases, foods are actually cooked prior to being packaged and stored. In other cases, cooking is neither appropriate nor necessary. For example, uh, treatment of milk. It is neither cooked before preservation, and for that, pasteurization is done. You know, conventional method of pasteurization is heating milk to a temperature at about 63 degrees centigrade for 30 minutes, and then it is immediately cooled to room temperature. Milk also can be flash pasteurized, which is also known as HTST, that is high temperature for short time, in which raising its temperature to about 72 degrees centigrade for 15 seconds is done with equally successful results. Next one is ultra high pasteurization, in which higher temperature up to more than 35 degrees centigrade is used for about 2 to 5 seconds depending upon the need to kill even bacterial endospores. And this ultra high pasteurization is done for various products like milk, juice, soups, and all such type of things, wines, etc. Next, next comes as low temperature treatment of foods with low temperature. That is, lower the temperature, slower will be chemical reactions, enzyme action, as well as microbial growth. Each microorganism has an optimal temperature for growth and a minimal temperature below which it cannot multiply fastly. As the temperature drops from optimal temperature towards the minimal, rate of growth of the organism obviously decreases and is slowest at the minimal temperature. Cooler temperatures prevent growth, but slow metabolic activity may continue. It is not necessary that even metabolic activities will stop. Most bacteria, yeast, and molds grow best in the temperature range of 16 to 38 degrees centigrade. Obviously, exception is psychrotrophs, which will grow even at lower temperature. At temperatures lower than 10 degrees centigrade, growth is slow and becomes slower the colder it gets. Principle behind refrigeration and freezing preservation is slowing of microbial activity with decreased temperatures. Next one is drying, which is one of the oldest methods of food preservation. It reduces water activity sufficiently to prevent or delay microbial growth. Water activity is related to relative humidity. Relative humidity refers to atmosphere surrounding a material or solution. Water activity is ratio of vapor pressure of the solution to the vapor pressure of pure water at the same temperature. Under equilibrium conditions, water activity equals relative humidity divided by 100. At usual temperatures, permitting microbial growth, most bacteria require water activity as low as 0.90 to 1. Some yeast and molds grow slowly at water activity as low as 0.65. Food is dried either partially or completely to preserve it against microbial spoilage. Next method comes irradiation. Lethal effects of radiation on different pathogens has been known for many years. Radiation is used for food preservation. For this, normally gamma radiation from radioactive isotopes or machine-generated X-rays or electron beams are used. One of the first applications of radiation for food preservation was treatment of various kinds of herbs and spices, which is an application approved by the United States Food and Drug Administration in 1983. So it was started in 1983. But even in 1985, the FDA extended its approval to be used for radiation of treatment of pork as a means of destroying the pathogens that cause trichinosis. This is problem caused by consumption of raw or semi-cooked meat. Experts predict that ease and efficiency of food preservation by means of radiation will develop considerably in the future. Preservation of food through irradiation. Radiation processing involves exposure of food to short-wave radiation energy to achieve a specific purpose, such as extension of shelf life, insect disinfestation, and elimination of foodborne pathogens and parasites. Compared to heat or chemical treatment, irradiation is more effective and appropriate technology to destroy foodborne pathogens. It offers number of advantages to producers, processors, retailers, and consumers. Now let us see type of radiation. Type of radiation used is limited to radiations from high energy gamma rays, X-rays, and accelerated electrons. These radiations are also referred to ionizing radiations because their energy is high enough to dislodge electrons from atoms and molecules and convert them to electrically charged particles known as ions. Gamma rays and X-rays like radio waves, microwaves, ultraviolet and visible light rays form part of electromagnetic spectrum and occur in the short wavelength, high energy region of the spectrum and have the greatest penetrating power. X-rays with varying energies are generated by machines. Gamma rays with specific energies come from spontaneous disintegration of radionuclides, naturally occurring and man-made radionuclides called radioactive isotopes or radioisotopes emit radiation as they spontaneously revert to a stable state. Time taken by a radionuclide to decay to half the level of radioactivity originally present in them is known as its half-life and specific for each radionuclide of a particular element. Only certain radiation sources can be used in food irradiation. These are specifically radionuclides as cobalt-60 or cesium-137, which are used for food irradiation commonly. X-ray machines have a maximum energy of only 5 million electron volts, or electron accelerators have a maximum energy of 10 million electron volts. Energies from these radiation sources are too low to induce radioactivity in any material, including food. Now let us see unit of radiation dose. Radiation dose is the quantity of radiation energy which is absorbed by foods as it passes through the radiation field during processing. It is measured using a unit called the gray. In early work, unit used was the rad. 1 gray is equal to 100 rads and 1 kilo gray is equal to obviously 1000 gray. Now let us see application of radiation processing of foods. Interest in practical application of the process is emerging for many regions, including high food losses caused by insect infestation, microbial contamination, and spoilage, mounting concern over foodborne diseases, harmful residues of chemical fumigants, and impact of these chemicals on environment, stiff standards of quality and quarantine restrictions in international trade. Though irradiation alone cannot solve all these problems of food preservation, it can play an important role in reducing post-harvest losses and use of chemical fumigants. On the basis of radiation dose, applications of radiation can be classified into low dose applications, medium dose applications, and high dose applications. We will see where low dose applications is being used. It is used at the level of 0.03 to 0.15 kilogray for sprout inhibition in bulbs and tubers, at a level of 0.25 to 0.75 kilogray for delaying of fruit ripening, and at a level of 0.25 to 1 kilogray for insect disinfestation, including quarantine treatment and elimination of foodborne parasites. Medium dose applications are used for reduction of spoilage microorganisms in order to improve shelf life of meat, poultry, and seafoods under refrigeration at the level of 1.5 to 3 kilogray, and elimination of pathogenic microbes in fresh and frozen meat, poultry, and seafoods. For this, amount of radiation is used at the level of 3 to 7 kilogray, and it is used at a level of 10 kilogray for reducing number of microorganisms in spices to improve its hygienic quality. High dose applications, that is at a level of 25 to 70 kilogray, is used for sterilization of packaged meat, poultry, and its products, which are shelf stable without refrigeration, and also for sterilization of hospital diets. So lastly, we will see different advantages and disadvantages of radiation processing of food. Radiation processing is a cold process, and therefore, unlike heat, it can be used on agricultural commodities without changing their fresh-like character. This is one of the important advantage of radiation processing. But radiation processing is a need-based technology and cannot be applied to all kinds of foods. Radiation processing does not alter significantly nutritional value, flavor, texture, and appearance of food, but it cannot make a bad or spoiled food good looking. Radiation using cobalt 60 cannot induce any radioactivity in food and does not leave any harmful or toxic radioactive residues on foods, as is the case with chemical fumigants. But it cannot destroy already present pesticides and toxins in the food. Due to the highly penetrating nature of the radiation energy, it is a very effective method. But amenability of a particular food commodity to radiation processing has to be tested in a laboratory. Prepackaged foods can be treated for hygienization and improving shelf life, but only those foods for which specific benefits are achieved by applying appropriate dosage, and those duly permitted under the Prevention of Food Adulteration Act rules 1955 can can be processed by radiation. Thank you. Thank you very much. So this is all about preservation of foods.